Hey, DPeter67 here, and today I want to talk about alternative power sources for emergency preparedness. You know, if the power goes out and you don't have a generator, or you're in the field, you may need to recharge your cell phone, maybe recharge some batteries, something simple like that. And I'm not talking about big systems. Here I'm talking about for portable electronics. So without further ado, let's go ahead and talk about the meat of the system. And that'll be a solar panel. And talking about something you can carry easily in your backpack. You know, you can hang on your backpack and collect power during the day. Now there's two ways to utilize solar panels. You can use them directly to charge your unit that you want charged, or you can charge up a power bank, and we'll talk about that in a minute. Down here you'll see a couple of units. On the left is the Goal Zero. That's a 7 watt, rated at 7 watt power, and it's a really nice system that retails for about $80. And then to the right of that we have a Coleman Sunforce. That's a 7.5 watt system, and I picked that gem up for I think $35. And you can see there's a considerable size difference in them. Okay, we're going to look at the voltage output on both of these units real quick. And to do that, I've got a little voltmeter right here, and I've hooked it up to a 12 volt adapter because they both have 12 volt adapters on them. So first I'm going to do the Goal Zero. And on the Goal Zero, the voltage, I'm pulling 15.17. That's 15.17 volts off the Goal Zero in decent sunlight. Right. On the Coleman, try to get the same angle here. I don't want to be accused of not doing an equal test. I'm getting 16.55 volts, so that's basically almost a volt and a half more out of this smaller panel. I'm pretty impressed with the Coleman, actually. For about half the price, it's putting out another whole volt. Now, the power is termed in watts, and that's a compilation, a mathematical rendering of amperage and voltage. And I can't really do amps on here because it moves too much. So another test I want to do, another thing I want to show you is I want to show you that these will, by themselves, on the face of it, charge an iPhone 5, which is draws a lot of amps compared to the iPhone 4. So I'm going to plug this in, and if you hear the noise, what you do, that is now charging. While it's in sunlight, it is charging. Now, I don't know if you can see this. So hopefully with the light we'll be able to see it. No, it stopped charging. That's because I stepped in front of it. So it is charging. It is charging. And now it is charging. I don't know if you can see that, but if I step in front of the panel, it stopped charging. So let's try that with the other one, and the results are going to be the same. I already know that because I've already done this test a couple times. And again, it is charging. I can't really do it, but if I step in front of it, it has stopped charging. No, it's still charging. Nope, it stopped. Okay, so that brings up a point that when charging your newer electronics, one of the issues is going to be that you got to keep it in direct sunlight all the time, or you got to babysit it to make sure that you restart your iPhone whenever, or your iPhone 5 anyways, maybe some 4s, whenever you get a little bit of a cloud go by or an interruption in direct sunlight. So just be aware that this by itself is probably not your best option. Which is going to bring me over to these items. Let me readjust here. And I'm going to talk about them one at a time. Okay, the first item we see down here is the Guide 10 Plus. This is put out by Goal Zero. It comes with 4 rechargeable AA batteries and an insert to put AAAs in there. Now, in my pack, I run everything off AAA, so I put the insert and some AAA batteries in there for recharging. What that will do is that'll plug right into your solar panel, and your solar panel will actually charge your unit. Okay, now right now this solar panel is charging these batteries, and it'll charge those batteries up in the course of a couple of hours depending on the sunlight, and then you'll have a battery pack with which you can then set this to output. Now this is charging, and regardless of how much you cover up those panels, it's charging because it's charging off the stored energy in the batteries, not off the direct sunlight. So you can charge these during the day. Maybe you don't need to charge your phone during the day. Maybe you're at 85 or 90%, you know, at 12 noon. But maybe come 7 or 8 o'clock at night, you need to charge your batteries. You're down to 30%. You need to charge your phone. Well, how do you do that when the sun's out? You don't. So you store the energy on a unit like this. The advantage of this is that I can get 2 or 3 charges off of these batteries onto my phone. In addition, I can charge batteries for my flashlights or my radio or whatever else. So that's a real good option there. Now, the next option I want to show you is this is a Anchor. This happens to be 10,000 milliamp, which is very respectable. And I'm going to plug into here. Move this Goal Zero over here. And I'm going to plug this Anchor into this panel. And I don't know if you can see those lights, but it is charging right now. So I can charge that up and discharge it, get several charges off of this one battery. Anything that can charge off a USB will charge off of this unit. I can charge this up, and at both of these, both of them will charge off your computer, off the wall, through the USB port, no problem. All right. This Ultralast Green will charge 2 AA batteries. It'll take basically all day to do it, but you'll have 2 batteries that you can use in maybe a flashlight or a radio or whatever. And this is about 15 bucks. I got to tell you, I'm highly disappointed in this. It was only a $20 purchase, and so far I have not been able to get it to work correctly yet. Now, you're supposed to be able to use it as 5 volt 1 amp output, 5 volt 2 amp output, 9 volt 1 amp output, and it's supposed to tell you the battery life in here with these LEDs on this side. And so far I've tried charging this with regular wall power, with my computer, and with the solar, and I've not been happy with it. So now to give you a rundown, this panel is going to run you about 80 bucks. This panel is going to run you about $35. This will run you about $40. This will run you about $40. This one right here, if you choose to try it, it's going to be about $20, and you can pick these up for about $15. So either one of these systems, and I highly recommend you look at the Coleman Sunforce 7.5 watt. It's a nice compact power package. It was putting out a lot of power. I'm really impressed with it over the Goal Zero. So hope that gives you some options to look at. Again, it's Deep Heater, and I hope this helps you out. Thanks.